a brand new Lambo.
Consider the following question. Nora scores an 88 on a math test and had a mean score of 80 and a standard deviation of 5 among all scores. But she also scored an 80 on her science test, which had an average score of 72, and the standard deviation of all scores in that class were 3. On which test did Nora perform better relative to the other students who took those exams? So at first thought, you may look at the overall scores and the fact that she had an 88 on the math and an 80 on the science and say, well, she did better on the math test. But if I look at the mean scores, the average on the science test was much lower than that on the math test, meaning that that test overall was significantly harder. So even though she scored a lower score, it was on a harder test. So we need a means by which to compare all of this information together. And that's where we're going to use something called a z-score. A z-score is a standardized way for comparing the relative position of any given observation to its mean, factoring in the spread of the distribution. It's calculated by the overall deviation of a data value x from its mean divided by the length of each standard deviation. The z-score, if it's greater than the mean, will be positive, and it's less than the mean will be negative, so it also gives me the direction that this data point falls relative to the mean. Let's calculate Nora's z-scores for her two exams, math and science. I can see that her z-score for math, which is her 88 minus the average of that exam, 80, divided by the standard deviation of that exam, is 1.4. This means that Nora's score of 88 is 1.4 standard deviations above the mean of 80. On her science exam, Nora's score of 80 falls 2.67 standard deviations above the mean. This tells me that overall, Nora's score of 80 in the science represents a relatively better performance as compared to her score of 88 on the math test. So Nora appears to have performed better on her science test relative to the other students who took that exam. Here's another example. On a standardized test, test scores are normally distributed with a mean of 60 and a standard deviation of 6. What is the z-score of a value of 48? So if I plug that into the z-score formula, it would be 48 minus the mean of 60 divided by the standard deviation of 6. And we will get -2. That means that an individual who scored a 48 on this exam scored 2 standard deviations below the average. We can use the z-scores to compare two data sets and make determinations. For example, in number 3, the Dow Jones Industrial Average, or the Dow as it's sometimes referred to, is an index measuring the stock performance of 30 large American companies. It is often used as a measure of overall economic growth in the United States. So below is a computer output describing the daily percentage change in the Dow Jones for the first 3 months of 2009 and in the first 3 months of 2010. Note that the stock market was open for 61 days in the first 3 months of each year. A negative value below would indicate percentage decrease in the index for that day. So let's consider what happens if the Dow Jones increased 1% on a given day. In which year, 2009 or 2010, would such an increase be considered a better day for the stock market relative to the remaining days in that year? So here are my overall averages for 2009 and 2010, and the standard deviation, or the measure of the dispersion, of each of the days within that year. To directly compare these to see which day a 1% increase would be better, I can calculate the z-score of 1% in each of these 2 years. For 2009, a 1% increase minus its average divided by its standard deviation would represent 0.5 standard deviations above the average for that year. Whereas in 2010, a 1% increase would represent 1.1 to 3 standard deviations above the mean. So in 2010, the same 1% increase falls much further above the average for that year than it did in 2009. For that reason, a 1% increase in 2010 would represent an overall better day for the stock market. Since it's greater, a 1% increase is further above the mean or the average stock performance than in the previous year. So the z-score gives us a way to directly compare two similar data sets.